The reason we use polynomials is because we have nonlinearity in our data, but that nonlinearity can take on two different forms. The first form is a quadratic, and so this is the squared polynomial. And for this, we would have the linear term, and then we would enter the polynomial term, the x squared, that represents the quadratic function. And that means that there's one curve in our data. So it looks like the two curves on the right above, where we have this upside down U shape and then a right side up U shape in our data. And that's one curve. And then we have the two curve case, which is pretty rare in the behavioral sciences research, but it could happen. So it's this curve where we have, or function where we have one curve and then we have another curve, as can be seen in the very bottom right. So that would be the cubic polynomial term that will, and if that's significant in our regression equation, that will determine if we have a cubic function. Okay, so just so you're aware that that's the way that we determine which ones will be used, and that's the difference between those two polynomials. So again, the squared polynomial is the quadratic function, and the cubic, the x to the power of 3, represents a cubic function, which would be two curves. So something important to keep in mind is that we should probably assume there's a cubic relationship and enter that second polynomial, which is x to the power of 3. So that's cubing the predictor. And so we would do that and look to see its significance. And if that one is significant, then we would conclude it's a cubic relationship. If the x3 is not significant and the x squared is, then we would conclude that there's a quadratic function. If just the x by itself, the linear function, is significant and x squared is not and x cubed is not, then we would conclude that we have a linear association in our data.